So the inverse of A is equal to 1 over the determinant. So that'll be 15 minus, so negative 7 and negative 2 gives us 14. Then our modified matrix, so we swap A and D, so 5 goes here and 3 goes here, and then we change the signs on B and C, so positive 7 and positive 2. Okay, so this is going to become 1, so 1 times this matrix is just going to leave us with 5, 2, 7, 3. Okay, so this is our our inverse matrix. And so we would multiply this matrix on either side here. So it would look like 5, 2, 7, 3 times 3, negative 2, negative 7, 5 times matrix X is equal to, okay, so the inverse first, 5, 2, 7, 3 times negative 2, 4, 3, and negative 1. So when we multiply, now we multiply the inverse of A with A, which will give us the identity matrix 1, 0, 0, 1 times matrix X. Then we multiply inverse of A with matrix B. So let's see, that's going to give me negative 10 plus 6, then negative 14 plus 9, 20 minus 2, and 28 minus 3. So the identity matrix times matrix X is equal to negative 4, this is negative 5, and then 18 and 25. And we just solve for X. Now you can check your work by multiplying matrix A with matrix X and see if you get matrix B. So there is a way to check your work with these. Okay, so let's put all of this together and everything that we've been learning about matrices, and it all comes to this: being able to solve a system of equations with matrices. Here's how we do that. So we're going to write our equation in the same form as our last problem. We have matrix A times matrix X gives us matrix B. However, we're actually going to put variables into matrix X. And matrix A is going to contain all the coefficients of X and Y. And then matrix B is going to contain all our constants. So let's take a look at this. When we have it set up, then we're going to go ahead and solve it just like that last problem. We want to make sure that both our equations are in standard form before we begin. And so here we have negative 2x plus 3y is equal to negative 11, and 5x plus y is equal to 19. We'll set up our matrix by, let me get a eraser. We'll set up matrix A with the coefficients. So we'll start with the first one, which is -2, and then 3 on the y. Then the second equation we'll put on the second row, 5 and 1. Now matrix X, we'll actually put the variables X and then Y, which will then give us, we'll put in our constants of -11 and +19. Cool, there we have it. Now that we have our equation of matrices, we will find our determinant of A and the subsequent inverse. So 1 over the determinant is -2 minus 15 multiplied by our modified matrix. So we will swap A and D, so 1, -2, and change the signs on B and C. We will be left with 1, -1/17. That's our scalar. And then 1, -3, -5, and -2. We'll need to multiply the -1/17 through. So we'll have -1/17, positive 5/17 rather, and positive 3/17, and positive 2/17. We will go ahead and apply our inverse matrix to both sides of the equation. So here's our inverse matrix. Seventeenths. I can't write too fast or it does not pick up what I'm writing. Seventeenths. Okay, and then times our next matrix, A, times matrix X equals inverse of A times matrix B. So inverse of A and then B, which is just -11 and 19. Okay, now A and the inverse of A gives us the identity matrix. So we really don't need to multiply that because unless you want to be sure you have the correct inverse of A, so it's not a bad idea. And then we'll multiply the inverse of A with B. Alright, so we got some fractions here. Thankfully we're just multiplying these and they have the same denominator. Okay, so it'll be positive 11/17 plus, and let's see, 3 times 19 gives us 57, so we'll say 57 over 17. And then the next row, negative 55 seventeenths plus 38 seventeenths. So the inverse matrix and our variable matrix, matrix X, gives us just the variables. And this works out to be 68 seventeenths. And this one works out nicely, negative 17 seventeenths. All right, now we will reduce our fractions. So 17 goes in 68 remarkably 4 times evenly, and that reduces to negative 1, the negative 7 seventeenths. Okay, so we have our x. X is equal to 4, and y is equal to negative 1. Don't forget, this is a point on a graph, an ordered pair, so we will write it, our solution, as an ordered pair. So 4, negative 1. And that is our solution that will work for both equations, and hence the system. So the nice thing about matrices is that, let's say this was a system in 3 variables. Well, that would be, solving it this way would actually be a lot easier to do than, let's say, using substitution or elimination. And we could expand to 4 variables and 5 variables. And matrices actually are easier, the more variables you throw in, as opposed to doing elimination and substitution. So in 2 variables it is a bit of work, and yes, elimination would probably be easier in this case, but as we expand to more dimensions, more variables, this would make a lot more sense, and now we know how to do that. So anyway, that concludes our foray with matrices, and really this is just the tip of an iceberg, a very large iceberg, dealing with matrices. There's an entire course that deals with this called linear algebra, and that's you'll learn that there's a lot to matrices, and it can get into some very, very interesting concepts. But that's all we're going to do for this course. So hopefully you got something out of it. Remember, you can go back and review things that you weren't, 100% picked up on, or you just need to go over, a second or third time. Anyway, I will see you on the flip side. Thanks. Bye.